We need to verify that the 4 points having these 4 position vectors are coplanar. Okay, let us begin. First, we will consider 4 points A, B, C, and D. So let A, B, C, and D be the 4 points. And we're also going to consider some origin O, and O be the origin. It's going to be the origin of some coordinate system with respect to which we are going to measure the position vector of the point A, B, C, and D. Then we have OA vector. The OA vector is going to be the position vector of point A. So that's defined as 6i cap minus 7j cap. Then we have OB vector. So OB vector is going to be 16i cap minus 19j cap minus 4k cap. Then we have OC vector. The OC vector is going to be 3j cap minus 6k cap. And then position vector of point A denoted by OD vector, that's going to be defined by the vector 2i cap minus 5j cap plus 10k cap. Now our goal will be to show that A, B, C, and D are coplanar points. So what we are doing here is we are selecting 4 points A, B, C, D. So let's say we have these 4 points and then we have the origin O. With respect to this origin O, we are defining the position vector of point A. We're defining the position vector of point B with the help of a directed line segment going from O to B. Similarly, we have a point joining O and C. This is another line, directed line segment, and then we have OD vector as well. So next what we'll do, we'll define AB vector, then BC vector and CD vector. If we can show that AB vector, BC vector, and CD vector, the 3 vectors are coplanar, then we can immediately say that A, B, C, D, the 4 points, are also going to be coplanar. Okay, let us begin by first obtaining the vector AB. Now, how do we find out the vector AB? All we have to do is use the definition. So that's OB vector minus OA vector. The OB vector is 16i cap minus 19j cap minus 4k cap. And from here, we're going to subtract 6i cap minus 7j cap. So here, we're going to get 10i cap. Then we have minus 12j cap minus 4k cap. Next, we'll obtain the vector BC. So BC vector, in terms of the position vector, that's OC vector minus OB vector. Now, what is OC vector? That's 3j cap minus 6k cap. And from here, we're subtracting the vector OB. So that's going to give us negative 16i cap. Then we have 3j cap minus negative 19. So that's going to be positive 22j cap. Then we have negative 6k cap plus 4k cap. So that's going to be negative 2k cap. And then finally, we're going to find out the vector CD vector. So CD vector is OD vector minus OC vector. So that's going to be 2 times I cap minus 8 times j cap plus 16k cap. So here we have obtained the vector AB, BC, and CD. We'll try to show that these 3 vectors are coplanar. Now, let's assume that AB vector, BC vector, and the vector CD, let's say these 3 vectors are coplanar. If they are coplanar, then by definition, we can pick up any one vector at a time. So that means let's pick up AB vector and we can represent it as a linear combination of the other 2 vectors. That means AB vector is going to be equals to x times the vector BC added to y times the vector CD. Now what's x and y? X and y, these are 2 scalars. These are going to be some real valued scalars. Fine, they are scalars. Now let's substitute the value of AB, BC, and CD. Now AB is going to be 10 I cap minus 12 j cap minus 4 k cap. So this is going to be equals to x times the vector BC. So BC is going to be negative 16 I cap plus 22 j cap minus 2 k cap added to y times the vector CD. So CD vector, that's 2i cap minus 8 j cap plus 16 k cap. Now we're going to combine all the like terms and take it to the left hand side. So here we have 10 plus 16x minus 2y. This is going to be the coefficient of I cap added to negative 12 minus 22x plus 8y, that will be multiplied to j cap, and then we have added to it negative 4 plus 2x minus 16y multiplied to k cap, and this must be equals to not 0 but the null vector 0, because on the left hand side we are working with vectors. There we're taking the sum of vectors, so on the right hand side we should also get a vector, and it's going to be the null vector. However, we know for a fact that the vectors I cap, j cap and k cap non-collinear. We know that they are non-collinear because they are perpendicular to each other. If they're non-collinear, then this equation is only going to be true if the coefficients of I cap, j cap and k cap are 0 simultaneously. So we have 10 plus 16x minus 2y. This must be equals to 0. We're going to call it equation number 1. And then we have negative 12 minus 22x plus 8y. We're going to call it equation number 2. And we have the coefficient of k cap, so negative 4 plus 2x minus 16y. This must be equals to 0 as well. And let's label this as equation number 3. Next, what we'll do, we'll take any two equations at a time and solve for the value of x and y. And whatever x and y value we get, it must satisfy the third equation. So let's begin by solving equation 1 and equation 2. Now we are going to get x equals to negative 2/3 and y is going to be equals to negative 1/3. Now what we'll do, we will check whether if this satisfies equation number 3 or not. Now we substitute x equals to negative 2/3 and y equals to negative 1/3 in equation 3. So we get negative 4 added to 2 times x, so x is going to be negative 2/3 minus 16 times negative 1/3. Let's find out the value. This is going to be equals to negative 4 minus 4/3 plus 16/3. This is going to give us, we have negative 4. Now 16/3 minus 4/3, that's going to be positive 12/3. Now positive 12/3, that's simply 4. So negative 4 plus 4, so that's going to give us 0, which is the right hand side. Now that means these two values, x and y values, which has been obtained by solving 1 and 2, is satisfying equation 3. Now that is possible because the vectors AB vector, BC vector and CD vector were coplanar, and because these three vectors are coplanar, then we can immediately say that points A, B, C and D are also coplanar. So we have successfully verified that the 4 points whose position vectors are given to us are coplanar.